Okay, right now let's look at 15.1. Let me try to explain the idea of definite integral. So definite integral is basically to find a value, right? What are we finding actually? We are actually finding the area under the graph. Alright, this area under the graph. So what's the best way to find the area under the graph? What is suggested here is to use vertical strip, use thin vertical strips. Alright, so why must it be thin? So let's take a look. Let's say if I were to use a very thick vertical strip, this strip over here, so the difference will be this times this. So will the area be close to the area I've shaded earlier? No, right? The area of this rectangle, red rectangle, as compared to this entire area, will it be close? Obviously, no. But what about if I were to draw two rectangles? Will the area of these two rectangles be close to the area? Still, the answer is still no, but at least it's better than the previous try. What if I draw three? Will it be even better? I guess so, because I cover more area. And what if now I draw 4? Oh, the area is actually closer. And now more and more rectangular vertical strips. The area will get closer and closer. So how many vertical strips will draw? We will let it be n. Okay, n be the number of vertical strips. We let it tend to infinity. Then we can find the area. This is basically area. The base times the height, the height times the base of the rectangular strips, individual rectangular strips. So we limit it to infinity. That means I have so many of these rectangular strips. Then it will give a very good approximation of the area under the graph. Alright. So this is a curve. So it's quite difficult to understand. Right? This is a curve. So it's quite difficult to visualize. We have to use rectangular strips to understand. But what about trapezium? Okay, we have a straight line which form a trapezium. Is it easier to explain? Let's see how to find the area of this trapezium. Okay, as mentioned, the geometrical shape, it is a trapezium. Can you recall the formula to find a trapezium? Okay, you should have learned this in Amath. The area will be half times sum of sides. The sum of sides will be, alright, I need to calculate. Okay, actually it's quite easy to calculate. You sub in 1 and you sub in 5 into this equation. Alright, so this is 1, 4. This is 5, 8. So this will be 4. This will be 8. So sum of sides, 4 plus 8, multiplied by the so-called height, but for this case is the base, which is 4. If you evaluate, you get 24 units square. So if integration is really, if definite integral is really finding the area on the graph, then we should get 24, right? So let's try. What is the fx in this question? The fx in this question is this formula over here. Alright, so that means fx is equals to x plus 3 because this represents the line, the straight line. So I will integrate x plus 3 dx. What is the lower limit? What is the upper limit? Okay, this is a good time to explain. The lower limit will be 1, the upper limit will be 5. 1 and 5, because I'm sweeping the area from x equals to 1, I sweep towards x equals to 5. And so integrating x plus 3, it should be very easy for you after so many practices. There's no need to put plus c because this is definite integral. I'm going to sub in 5 and 1. And you substitute 5 in. Minus away, you substitute 1 in. And your answer, you press your calculator, you also get 24 units square. So what can we say? We compare the results 1 and 2. What do you notice? We notice that the area is the same. The area found in 1 and 2 are the same. So we can conclude that a definite integral may be taken to be the area under a graph. Okay, the graph can be a curve or straight line. Alright, so this part we have concluded that integration, basically definite integral, we are finding area